So this is the second part of this section, and we're going to talk about visual perception and art. You might be wondering again, why is this topic important? And like we said in the last slide, that there's a lot you can tell by how somebody draws, what they're having problems with. And if you're ever going to teach people how to draw or how to draw yourself, you really need to understand how what we see is put on paper when we draw. And so we will also cover drawing what you see and look at some tricks of the artist of how they know the eye operates and therefore how they translate that in a visual image. So let's talk first about how we see. And one thing that's really fun to do to help connect how we see is making something called a thaumatrope. And what a thaumatrope does, you draw one image on one side and draw the image upside down on the other side, and the images go together. And so in this one, you see a bird cage. So on one image, you have a bird cage upright, and when you flip it over, you draw the bird upside down. And when you wind it up together in its flipping, your eye sees them as one. How does our brain take two separate images, a bird cage and a bird that are not together, and connects them together to understand them? And part of this is the process of what we see concretely, which is an image of a cage. On a separate sheet, we see an image of a bird. And when they're moving together quickly, our brain says, oh, that's a bird in a bird cage. So our brain takes this data, this raw data of these images, and puts them together to make sense. And so if we were doing this in class, we would actually make one of these together. And you could do this. Some people do like an umbrella and rain. And you could have fun and look at some of these sites and see what people create. And so taking this similar concept, I want to know what you see in this image. Some of you might see apples or might see, I don't know, peaches. And now when we zoom out of this image and we see the whole thing together, you see something totally different. And so this is a Chuck Close painting, and Chuck Close made paintings by almost pixelating and doing a grid, which we'll learn a little bit about later, of the colors. And when you take a big picture look out of the whole thing, like our brain does, when it can put everything together, it makes more sense out of it. So looking at something as the concrete raw image of just these colors together versus putting the whole thing together is how our brain makes sense of visual images. And so we'll talk about how this works. And so what our brain is doing is taking raw sensations, which are physical energy, seeing these colors, and our brain makes sense of things where it takes the interpretation of things and makes sense of it. And so what we call this processing is bottom up, which is our raw sensory information that we make sense using higher level thinking to interpret things. And so the two things work together, the raw sensory information and our brain putting things together to make sense of it. Experiences can be recorded in our body through our senses, and then we might make sense out of it through our brain. And so both of these processes work together, and we can also use those in therapy and in understanding whether somebody's experiencing something just through their senses or making sense out of it cognitively. What is interesting is a lot of people think of our vision system as separate from our brain, but the axons of our eyeballs actually form the optic nerve, which goes directly into our brain and is part of our brain system. And that's why if our brain is being affected by something, we're going to see changes in our vision. And so a lot of people don't know, but a lot of diseases like Alzheimer's, Parkinson's, you will also have changes in vision. So the raw data that we actually see are light waves, and these light waves are what reflect on the things in our environment, and those reflections go into our eyes, and that's what we see. And so one thing that you're going to do is draw an eyeball, and if you use this video to watch, you will take a penny and draw the circle of the eye, then we'll draw the outer coating of the cornea here, and then this is the optic nerve here, and you'll label all of these all together in an image. So go ahead and take your time and draw that out and watch that video. Now we're going to label all these elements. So the cornea is the outer cover of the eye that is clear. This holds the shape of the eye. And our pupil is an open space in our eye that lets the light come in. The iris is the coloring of the eye, which controls the amount of light we let in. The lens focuses the image, and the image, the way the light bends, shows upside down on our retina. And our retina is filled with these cells, and these cells interpret different elements of the visual image that we see. Our cones and our rods, our bipolar cells, and our ganglion cells then form the axon that goes to our visual cortex. And so you might want to pause here, go back to the last slide, label all the different elements so that you have the eye diagram with the labels all in one place. Again, this image or the axons of these ganglion cells go to the brain and they're sent to the visual cortex. Okay, I should have given you a warning for this side. If this is disgusting, go to the next slide. But I was in a class where I got to dissect a cow eyeball and I took pictures to label these for you. So here's the cornea, which is the outer layer. You see the iris here with the muscles. The lens is this piece right here along with the fluid that fills and shapes the eyeball. The optic nerve you can see here, and that goes to the brain. And then these ciliary muscles also hold the eye together. So now I was going to have you draw the outline of the brain with the eye, and you can do that if you want to. So we talked about the cerebral cortex that is in charge of is higher level thinking and is made up of these 4 lobes. We're going to primarily focus on the occipital lobes and some visual streams, although I'm not going to go into detail of those. If you want to read about these visual streams in more depth, you can in your book, but our brain is really complex the way it processes visual materials. There is a stream that processes where something is and a stream that processes what it is. And so those are sent to other parts of the brain to fully process what we're seeing. Again, our brain is taking sensory, raw information, connecting it to our higher level thinking to make sense of it. So again, those 2 processing levels work together to understand what we see. And again, just re-emphasizing, we take raw information, we put it into more conceptual understanding, and it makes more sense to us. Eric Kandel is the one who this section of slides is primarily based off of, and he wrote the book Art in the Brain of the Beholder, and He talks about the human brain processes abstract art differently in terms of line, color, form, and texture. We know that our neural circuitry is hardwired to prefer images we can identify, which makes abstract forms more difficult to process. So now we're going to talk about how the understanding of the eye and how the eye works can help you draw what you see. And so if you can connect your understanding of vision to learning how to draw, you can really learn to draw exactly what you see, lines and shapes, not what you think you see. And this will really help you fine-tune your drawing. And so by drawing what you see, we are going to pay attention to 6 of 7 monocular cues. And here are the ones here. So if you look at this picture of the Taj Mahal, using these cues will help you draw something that looks more three-dimensional and has perspective. And so each of these 6 monocular cues are highlighted in this image. And so we'll go through those one at a time. The first one is linear perspective. When you are looking at something in the distance, it almost looks like it stops at this point here. Using a point and drawing your lines to that point creates this perspective that something is going off in the distance. Using linear perspective, you can watch this video that talks about how using that one point can help you draw all these elements to create perspective. And I want you to try this in your notes. Watch the video, put your point in, try to draw these railroad tracks using the point and give your image perspective. You can pause the video here. Interposition is where something in front of us covers up something behind us. And so using interposition in your drawings helps us know these buildings that are covered up are in the back and these buildings that we can see are in the front. Relative size also creates depth. So this person looks about half the size as this person, although we know they're probably all about the same. This person we know is up close because they're so large. So using relative size can also help create more depth in your pictures. The next one is texture gradient. Things up close look more detailed than things far back. They look more smooth, and so drawing more details up front and more smooth, less details in the back creates this texture gradient, which creates depth in drawings. Light and shadow can also give a sense of 3 dimensions, and so you just saw that here, that if we create some shadows, if we imagine light coming down and creating shadows on one side and creating a shadow here, that's going to create depth. Heightened plane is that things up close look down compared to things further away, so you can also use that to create more depth in your images. So when you're teaching others to draw what we see, you want to tell them to draw exactly what you see, lines and shapes, the raw data, and not what we think we see. And so again, just we know these railroad tracks are the same size all the way through, but we draw them as if they're ending in a point to help create depth, because that is actually the raw material that we see. In this video, you can watch how to use grids. The grids help break things down into components that help you draw exactly what you see versus what you think you see, which helps you get a more accurate drawing. You can pause here and watch this video if you want. You might also be wondering what adaptations might we make if somebody does have some visual impairments. One thing you can do is label things with things that people can touch so that they can feel differences between what they're touching. Using painter's tape creates edges and people can feel that. Placing tools within sight or telling people this is on your right side can help people with visual impairments create art. So now we're going to shift and talk about current approaches to neuroscience. One thing that you should know is that the studying the brain and neuroscience and art has really shifted to looking at brain networks, and we now know multiple networks work when our brain is doing different tasks. One part of the brain you will hear a lot about is something called the default mode network, and we really believe this is activated when we are drawing and in a flow state. And in this state, we become more internal, more reflective, and it might be one of the reasons why art making helps people express themselves more in therapy. The central executive network is operating when we're thinking, making decisions, and the salience network is what shifts between the default and the central executive network. And so it might be that in art therapy, these three networks are operating and might be why art, this internal reflective flow state, assists in the central executive network and helping people open up their ideas and thinking clearly. Finally, there are a lot of new ways to study the neuroscience of art therapy. We now have EEGs, and there have been studies on EEG art materials in the brain. We now have measurements for cortisol, and that has been a commonly studied thing with art therapy. Cortisol is a stress hormone, and there have been several studies that have looked at when engaging in art therapy, cortisol level lowers. And we have also just begun to start looking at brain scans in art therapy, functional near infrared spectroscopy, functional magnetic resonance imaging, and newer technology are more mobile wearable equipment. And so if art therapists can find the funding to use more of these neuroscientific ways of studying things, it'll be really interesting to see how art therapy affects the brain.